SwayamPrabha. Digital India. Educated India.
Hello everyone and a very warm welcome to all of you to this gas turbine and jet engines course. Okay. So, this is a NPTEL certification course, and in this course we are going to learn about the different aspects of gas turbines and jet engines, their working principles and how to do performance calculations related to gas turbines and jet engines. Okay. So, today we will start with an introduction of what is a gas turbine, how it works, and what are the applications of gas turbines, so as to get a good idea about the say different aspects of gas turbine which are important. Now, let us start with what is a gas turbine. Okay. So, it is a type of heat engine. It is a type of heat engine. Heat engine you already know, like for example, ICE engine, reciprocating engines are also heat engines. So, the role is to convert thermal energy into mechanical energy. Okay. So, that mechanical energy can be used to drive some sort of mechanical device or shaft, or it can be used for electrical power generation also. So, in the case of gas turbines also, the mechanical energy of whatever is present in the fuel is converted to rotational motion of the shaft. Okay. Through the use of a system which is known as a turbine, and this motion of the shaft can then be used to run compressors, run generators, or in the case of aircrafts this can be used to run propellers, or it can also means with auxiliary devices like nozzles we can also generate thrust in the aircrafts. Okay. So, how does what is the basic working principle of gas turbine? Okay. So, you can see a typical image of a gas turbine here. Okay. So, it consists of a set of rotating parts. So, the core section is a single solid shaft. In this case there can be multiple shafts also, on which there are rotating parts which are installed. So, these are known as compressors, and the another set of rotating parts are known as turbines. So, the compressor, what does it do? It so at the intake air comes into the gas turbine and it gets compressed, it goes to a high pressure in the compressor, then fuel is injected in chambers which are known as combustion chamber, and the fuel gets combusted. Basically, there is a chemical reaction between the fuel and the oxygen present in the air, and these combustion products which are now at a high temperature, it can go to very high temperature, but by design it is kept at a controlled temperature, so that the turbine blades do not fail. So, this high temperature fluid impinges on the turbine blade, okay, and that makes the turbine blades move and generates the rotation of the shaft. So, this rotation of the shaft itself is what drives the compressor, and this shaft also can be connected to generator shaft. So, in this case for power generation, where the shaft also moves the generator shaft and creates electrical power. Okay. So, in a nutshell, that is the way a gas turbine works. Okay. So, if we want to simplify the process, there are three basic processes in a gas turbine. Compression of the air, this is done using a compressor. So, fresh air is brought forward and passed through a compressor, then combustion, which is the chemical reaction between the fuel and the air or oxygen present in the air. Then this hot air is passed to the turbine and it expands. So, this process is known as expansion, where the pressure decreases. Any process where the pressure decreases like this will be called as expansion. So, this is the expansion process, and in this the turbine generates work through the rotation of the shaft. Then that work is part of the work is used for running the compressor, part of the work is used for running a mechanical drive. That we have already explained, can be generator shaft, it can be a propeller of an aircraft, or it can be the shaft of a helicopter propeller, okay, or shaft of a marine engine. So, things like that. So, in summary, rotary, so these are rotary internal combustion engines. Here also the combustion occurs internally, means the working fluid takes part in the combustion, and this work at a steady state condition, unlike reciprocating engines. Here there is a continuous rotational motion of the turbines, and the flow also occurs continuously. So, everything is at steady state, which means that the power delivery is also very steady as compared to reciprocating engines, and because it is inherently rotational. So, when driving a rotational device like propeller, this is much more advantageous as compared to reciprocating engine, where there are balancing issues. Ambient air is compressed, mixed with fuel, burned at constant pressure. High temperature gases expand through the turbine to produce shaft work. Part of the turbine power drives the compressor, rest is useful output, okay, or rest is used for creating work output in some form. And the fundamental thermodynamic cycle for gas turbines is the Brayton cycle, and there are various modified versions of it, which we will study in the course. So, here you can see the schematic, and the same working principle means you can just think of this schematic and think how the different processes occur, starting from the intake, the compression process, we will not go into detail to save time. Then how the combustion occurs, you can see the arrangement of the components starting from the intake, then the multiple stages of compressors. Each stage is like a fan with a large number of blades, okay, they rotate and push the air. So, this high pressure air comes to the combustion chamber, gets combusted, hot gases pass through the turbine blades, which are also similar to fans, but here the air comes at high energy and pushes the blade on the other way around, and the blades rotate, rotating the shaft. Okay. And finally, we have the, for this is from a jet engine. So, we have a nozzle where the exhaust gases go out at high speed. So, jet engine working is slightly different, little bit different as compared to industrial gas turbine. In industrial gas turbine, we will have more stages of turbine, and more amount of work will be created, and that extra work will be used for running the external load like generators. Whereas, for jet engines, less number of turbines are required, because turbines only are present just to run the compressor. So, lot of energy still remains in the fluid after expansion in the turbine. That energy is used through when the fluid is passed through a nozzle to accelerate the fluid to high velocity, and this high velocity fluid coming out from the nozzle creates a thrust on the aircraft engine, which propels the aircraft forward. Okay. So, these are the two basic versions of, or you can say primary divisions of gas turbines. One is industrial gas turbines, or gas turbines which use mechanical, means which are there for running mechanical shafts, and the second type is for aerospace application, like for aircraft propulsion. Okay. So, as I was already explaining the different types of gas turbines, based on application, we can see that the major divisions are aero gas turbines or aircraft propulsion gas turbines, and within this again there are different types like turbojet, turbofan and turboprop, which we will study later for different applications. Then industrial gas turbine, these are used for power generation. This can also be used for mechanical drives, where these are coupled directly to some shaft which is used to run, say for example, a large pump or a compressor, okay, like in oil industry, a drill, the drill bit of the say offshore rig, this type of things. And these are also used for other means applications where propeller is run by using a shaft, which is known as the turbo shaft gas turbine. So, these are used for helicopters, then for marine propulsion, like say large military ships like destroyers also use gas turbines. Based on cycles and based on the nature of the thermodynamic processes involved, we can have another set of division. So, starting with simple gas turbine, which is the most common type of gas turbine. Then there are various augmentations which are done for industrial gas turbines, but not for jet engines. Okay. So, these are known as regenerative gas turbine, we will study all this later on. This is for getting more efficiency, and then reheat gas turbine and intercooling gas turbine, where we want to get more work output from a same size of the engine. So, more specific work output. Okay. Now, let us come to the applications of gas turbines. So, I have shown some of the important applications through examples here. So, this is an example of gas turbines being used in a power plant. Okay. So, gas turbines are used quite widely for power generation, but they are used in two ways. One is that in the case of moderate size power plants. Okay. So, unlike say very large thermal power plants may generate power of the order of gigawatt, okay, very large amount. So, it will have multiple steam turbines, and they are very large structures, and they create or they generate very large amount of power. In contrast to that, gas turbines are designed for faster operation, means they start much more quickly. So, the steam turbines and the furnaces for thermal power plants take a lot of time, hours to start, whereas gas turbine takes only few minutes to start and get up to full power. So, these are there when you need faster response to load requirement, like there is power fluctuation requirement in power flux, means fluctuation is power requirement. In that cases, the thermal power plant based on steam turbine will take a lot of time to adjust its power as per the required power, okay, but for gas turbines it is easier. So, they are for smaller plants like of the order of 100 megawatt, 50 megawatt, things like that. They are also used combined with steam turbine plants, like as part of thermal power plants. These are known as combined plants or combined cycle plants. Okay. Either the cycle can be directly combined in case like the steam cycle as combined with the gas turbine cycle, or they can exist parallelly, and part of the load can be generated by the gas turbine, and the base load or the bulk of the base load is generated by the steam turbine. So, the gas turbine is there to cater to any fluctuations or to cater to any sudden requirement or sudden jump in load requirement. In those cases it is very helpful. So, you can see one example of a combined cycle power plant. Okay. This is known as the gateway generation station, and we will not go into further detail of this, but you can see the various ducts and the stacks and basically the engine housings here. The next major application, and this is the one of the most important application of gas turbines, and also from research point of view or study point of view also this is the most important, because lot of organizations work on improvement of aircraft. So, this is aircraft propulsion. So, jet engines are nowadays universally used for aircraft propulsion. In initial days of aircraft development in the 1900s, early 1900s, aircrafts were designed with engines which were similar to or derivatives of automobile engine. Okay. At that time automobile was also new, and these mechanical systems were new say inventions. So, automobile engines, reciprocating automobile engines were used for running a propeller which used to run the means generate thrust and propel the aircraft forward. These had multiple difficulties in the sense that they were very bulky. There was issue with lubrication and long term maintenance or long term usability. Then there were load balancing issues, because you are converting a reciprocating type motion or load delivery to a rotary type load delivery. Okay. So, as a result, with time this jet engine got developed during the Second World War, and after that gradually most of this, almost all of these reciprocating engine aircrafts have been replaced by jet engines or gas turbine based aircrafts. Nowadays almost all passenger as well as all military aircrafts use jet engines. Okay. So, they are very widely used for aircrafts, and you can see some examples I have shown here, which are very interesting examples. So, one is at the top is aircraft with afterburner, which we will study later, which creates a lot of thrust. So, this is taking off from a short runway of a aircraft carrier. Okay. So, this is one of the famous military aircrafts, and this uses a type of jet engine with afterburner, which is a modification used for very high thrust generation. Another military aircraft also you can see. Okay. Similarly, this bottom picture is from a civilian commercial aircraft, which is, so this is a type of engine which is known as turbofan engine. So, these are used for large commercial aircrafts, and you have seen probably other pictures of also of large commercial aircrafts, or you must have seen, all of you, in airports and during say flight journeys, that how the aircraft engines look like. So, within this aircraft propulsion, again there are different types of engine. There are something called turbojet, then turbofan, turboprop. Okay. So, ramjet and scramjet, more experimental types of jet engines. So, we will also study them one by one in this course. Okay. All these are the part of the course, and we will go through each of this type of gas turbine and jet engine and study them in depth. Then the third important application. So, the another very important application of this propulsion or use of gas turbine for propulsion is in marine application. So, here you can see the British destroyer HMS Daring, which is run by Rolls-Royce WR-21 gas turbine. So, gas turbine engines. Okay. So, many of the military ships actually use gas turbines, which have very high power to weight ratio, like for the same weight they can deliver much larger power, okay, as compared to diesel engines. Another important application is offshore power generation, particularly say in the context of offshore oil rigs. You need power to run the entire rig, plus you need power to run the massive drills which are present for drilling on the like drilling through the rocks to go to the oil section, oil and gas section. So, this is one example. This is from the Norwegian oil and gas plant, which uses gas turbine. So, I have chosen the pictures which actually use gas turbine. So, this uses gas turbine for its operation. Okay. And similar types of means wide usage is there in other oil and gas industries also. So, another application for oil and gas industry is to use mechanical devices like pumps, very large pumps in oil pipelines, like oil pipelines oil flows for hundreds of kilometers. Okay. So, they need pumps to make the oil flow, and those pumps in many cases are run using turbines, gas turbines. Then another important application is use of gas turbines in helicopters. So, helicopter propulsion is also very important, right, and the way this is done is similar to the industrial gas turbine that we have studied. So, the gas turbine rotates the shaft, but instead of this being coupled to a generator shaft, this is coupled to a rotating fan, which is known as a propeller, a very large fan like structure with few blades. The number of blades can be 2, 3 or 4, or it can be slightly higher also depending on the helicopter. So, this is rotated at high speed, and this creates a thrust in the upward direction. Okay. And by changing the direction slightly for the propeller, you can create even forward thrust vectors, and directional thrust can be generated. Okay. So, here the propulsion is not done by using jet propulsion, like in the previous jet engines cases. The propulsion is done by propelling the exhaust gases at very high speed through the nozzle, and the role of the gas turbine is to run the compressor, so that the combustion occurs at high pressure, and we have a very large pressure for expansion in the nozzle. Okay. But whereas for this type of application, helicopters, there is no jet stream. So, here the momentum change occurs in the air due to the running of the propeller itself. Okay. So, this type of aircraft engines are also there, which are known as turboprop engines, but the propeller are mounted in the perpendicular direction. So, this is the famous helicopter Boeing AH-64 Apache, you must have seen it in many movies and other applications, very widely used attacking helicopter for military usage. This uses the GET 700 turboshaft engine, which is a gas turbine engine. Then other military vehicles also use gas turbines. So, you will see that there are many applications where actually this high thrust or high power relative to weight is required. Okay. So, these are used for tanks. Okay. So, this is M1A2 Abrams tank, again a very famous type of tank, and this uses Honeywell AGT 1500 gas turbine engines. So, these gas turbines run the mechanical drives for running the tank. Okay. So, there is no thrust generation here, the wheels are run or the rollers are run by using the gas turbine. Some other say niche areas or experimental applications have been there for gas turbines. Then some esoteric applications, means off the track applications or some sort of say exploratory interesting designs have been performed. So, I have listed couple of those, there are many other examples. I request all of you to go and search and find many interesting cases of use of gas turbines and jet engines in apart from these normal usage cases that I have shown. So, one example where jet engines were famously used was to attain the land speed record. Okay. So, land speed record is a record where the vehicle needs to be propelled over land, means it will be rolling on wheels, it will not fly. So, it will be rolling on wheels on land, and the record speed was very high, means it in the supersonic region. So, above the speed of sound, and that was achieved by using two massive jet engines, okay, mounted on a very aerodynamic platform. Okay. So, this is the famous thrust SSC land speed record vehicle, which was run by two large Rolls Royce jet engines. Okay. Similarly, there have been a production motorcycle, means which has been produced in numbers, which is known as MTT Y2K turbine motorcycle. This also used gas turbine to run. Okay. This also used gas turbine, and this was a turboshaft engine, a Rolls Royce 250 C18 turboshaft engine, similar to helicopters, but here it is driving the wheel. Okay. So, mechanical drive to the wheel. You can see that this is quite different looking, actually this looks very bulky. So, you can say that what you said, that for a less amount of weight we can generate lot of power. So, there is a minimum size that is required, but this generates a very high amount of power. So, I think around 420 HP or something like that, which is very large when it is considered in terms of motorcycles. It is means on a on a normal scale of motorcycles, this is towards the extreme end, and as a result the thrust to weight ratio or the power to weight ratio is excellent here also, but the system is still bulky. Okay. There have been other applications also, there have been interesting applications, although they have been banned. So, for example, in people have tried to use similar concepts in racing cars also, okay, and similar other devices. So, very interesting area. So, I suggest that after today's introductory class, you go through all these applications, go through some normal topics, go through Wikipedia and other normal books and topics, and try to understand gas turbines and their applications in a more general way. So, now the question is why gas turbines should be used. So, we can compare in two cases, one is for power generation. So, power generation we have to compare with other form of power generation. The most widely used form of power generation at this point is the use of steam turbines in a thermal power plant. Of course, there are also nuclear power plants which are widely used. Then nowadays lot of emphasis on solar plants and wind plants, but mainly still the bulk of the power is generated by using thermal power plants. And compared to thermal power plants, means steam based thermal power plants where steam is the working fluid, gas turbines have much faster response and startup time, okay, which I have already explained. Gas turbines, the gases are the air which comes in and gets combusted and goes out, very simple process. In steam turbines, the steam has to be generated, it takes a lot of time to start the furnace, to get it up to a specific speed, not speed, specific temperature, and then to generate the required quantity of steam continuously, then run the turbine. Okay. But those are efficient at very large scales. So, that is why these are still used at very large scale, and at a moderate scale or medium scale these gas turbines are used, or they are combined with steam turbines to get both the advantages. So, as I was saying, suitable for medium sized power plants and combined gas turbine steam turbine plants for fast load response with high efficiency, both are obtained. Okay. Now, when it comes to the other major application, which is aircraft propulsion, the comparison is done with reciprocating engines or rocket engines. Rocket engines are too costly and cannot be used for normal say aircraft flights. So, they are only used when say there is no possibility of air breathing engines like in space, or when we want extremely high speed, okay, and cost is not a factor. Rockets are generally very poor or have very poor payload capacity. So, most of the payload actually for rocket is its own fuel, because it has to carry its oxidizer as compared to jet engines, which just takes in air for oxidation. So, it has to carry but just its fuel. So, jet engine is more favorable as compared to rocket for normal flights at in the atmospheric conditions. Okay. Now, compared to reciprocating engines, initially reciprocating engines were very widely used. If you see the World War I aircrafts or even World War II aircrafts, you will see famous example of reciprocating engine based aircrafts. Very clever designs were made, and these although these were capable fully of flying, so there were many limitations. One was that system was too bulky. So, you cannot use just one or two reciprocating engines, you need at least a very large amount, 8 to 10 engines or 9 to like 9 engines or 11 engines to be arranged in circular fashion, so as to make the power delivery as uniform as possible. Inherently the power delivery is not rotary in nature. So, getting it done converted to rotary motion involves some balancing issues. Then there are also issues with the mounting of the propeller or mounting of the engine has to be mounted towards the front of the aircraft, not at the middle of the aircraft, which also causes control issues, right, maneuverability issues can be there. And then there are maintenance issues. Reciprocating engines needs lot of lubrication because of the piston cylinder arrangement, lot of maintenance and repair. So, those issues reduce the life of the aircraft. Okay. So, initial reciprocating engine aircraft had very short duration, like they were used for one flight and they used to just like use and throw type of situation. Almost negligible lifespan was there during World War I. Gradually things improved, and first passenger aircrafts also came with reciprocating engine, but once jet engine was developed, almost all reciprocating engines were replaced by jet engines because of the high thrust to weight ratio and because of their high reliability and high efficiency and lower weight. So, lower weight translate to more fuel economy and more efficiency. And the other major factor which we have not yet discussed is that they can take the aircraft to very high speed. So, if you are designing an aircraft with high speed, you cannot use a reciprocating engine with a propeller. So, propeller has to be run such that the tips of the propeller are still at subsonic speed. Otherwise, if it goes supersonic, there will be lot of turbulence which creates significant losses, okay, and significant stresses on the structure. So, modern high speed aircraft like military aircraft can only run using high speed jet for creating the thrust, and so gas turbines or gas turbine based jet engines are a very suitable method for that. So, these are some of the major reasons why gas turbines are used and why we will study gas turbines and jet engines. Okay. So, to summarize, gas turbines provide high power output along with compact and lightweight design. They are widely used for aviation, we have seen already examples, for power generation, for other industrial applications, and they are a key to modern and future energy requirements. So, there is lot of research which goes on at various organizations, various companies, government organizations on improving the gas turbines, their efficiency, their performances, okay. Jet engines, improvement of jet engine materials and jet engine blades, jet engine say efficiency, things like that. So, finally, just a word on the course. This course on gas turbine and jet engine hopefully will build a strong foundation for all of us, for you who are taking part in the course. So, it will build a strong foundation in aircraft propulsion and power generation. You will learn all the basics of aircraft engines and gas turbines and how they work, working principle, their design and their performance calculations, and hopefully will equip the student with analytical skills. So, you will get analytical skills, you will get trained on analytical skills, which will be very relevant for you if you work in the aerospace industry, energy industry, turbo machinery industry, defense industry, or say even in other research sectors. Okay. So, with this we conclude this first class of this course, and I hope that all of you have a very fruitful time in this course. You will learn a lot, and this will be very helpful in your future. Okay. So, these are the references that I have used for the images and for the other material. Thank you, and we will meet again in the second class.